other than circumference that you have. There's another formula coming today. And before we start, reminder, Tuesday you got a quiz on days 1 through 3. Okay, so you already know circumference will be part of it. Here is day 2. We are not reviewing on Monday. Monday we're going to do day 3, which is on the quiz, but the homework is a Delta Math, which is a review for the quiz. All right, so that's what's upcoming here. All right, let's start us off here with a new vocabulary term. A lot of times this year we've been dealing with one of these, which is called that's an angle. Great job, kids. Good job. I'm so proud you learned something. Where these two rays meet, let's talk about that. That was called the what of the angle? Oh boy. It's called the vertex of the angle. Perfect. All right, so now we're going to start putting angles inside the circle. And if it happens that the vertex of an angle is also the center, okay? The vertex of an angle is shared with the center. We're going to call that angle a central angle, okay? It's going to be called a central angle if the vertex and the center are the same point. So in my diagram right here, an example of a central angle is going to be angle AOB, okay? AOB. That is a central angle. Okay, because the vertex O is the center. Questions on that first type of angle? Well, I'm going to show you more, not today, but we're going to have more types of different angles inside. But this is called the central because the vertex is at the center. All good. Next up, zip it. You're killing me back there. Do we need to move?
No.
Actually, why don't you go? I say that. You're going to be yapping with that group and with that group. So there we go. Thank you. All right, a portion of the arc, an arc. That's a piece of the circle on the outside. Okay, a piece of the circle. So here we go. We could go from A to B. That's an arc. I could go from C to A. That's an arc. Heck, we could go really nuts and go from A to C to B. Those are all arcs. It's a part of the circle, right? Actually on it, which means we now need a new symbol. We need a new symbol now. All right, like we have line segment, we have line, we have an angle symbol. Well, now we need an arc symbol. And it's just what it is. An arc. Okay, an arc. Underneath it will be some letters. So let me throw 2 letters under here, arc AB. And we're going to compare it to another arc in this diagram. Now I'm going to put 3 letters, ACB. All right, how can you identify where those arcs are? Well, the first arc says AB. So you know what? Darn it, you follow the letters. A to B, stop. Nothing in between. A to B. So this arc, AB, would be referring to that piece of the circle. Well, why can't you go, counterclockwise the other direction? Because if I wanted that, what's in the middle there? C. So that arc is ACB. I follow the order of the letters to determine where the arc is in the diagram. Okay? You want me to go right to A to B, no stops in between? I'm doing it. Oh, now I go A to C to B, that forms a different arc. Questions? Yes?
What if there's no C?
There will be. Okay, I'll answer, let me come back to that because I will attach a vocabulary term I haven't taught you yet to it. All right, was that your question there, big boss? Or you good, Jake? You good? I thought you had your paw up. We're good? Anybody else? Okay, I'm going to skip over the theorem real quick. All right, I'll get back to the first theorem I'm going to show you about circles because since we're on the topic of arcs, I want to talk about 3 different types of arcs. And this will get back to Sophie's question. First arc's called a semicircle. I think you've heard of that before. Semicircle, half a circle. Also, we probably should jot down, anybody know the number of degrees? 180 in a circle. It's a half a circle, 360 in every circle, so a half of it's going to be 180. Okay? A major arc, that's something bigger than a semicircle. So it should measure over 180. That's called a major arc. And then the other one is called a minor arc, which is smaller than 180. All right, so smaller than a semicircle. So Sophie, let me answer your question right away. What if there was no C? I would attach minor arc AB, or major arc AB to it, so you know which exact one it is. All right, everybody good on that? I just wouldn't leave you hanging. All right, so here's what I need from all of you right now, and you can do it in your groups if you'd like. In this first diagram, please name, using appropriate notation, name a semicircle. In the second diagram, using proper notation, tell me a minor arc in that diagram. And then finally, I'm sure you can guess, in the third diagram, give me a major arc using proper notation. All right, let's talk. How about a semicircle in this first diagram, named appropriately? Because there could be two possible choices here. Oh, here we go. Violet, give me a semicircle. Arc. ST, fine. Yep. If anybody had TRS or those three letters in that order, that's fine too. ST is fine with me. I'm going right to S to T, no stops in between. How about a minor arc in the second diagram? A minor arc. We're going twos here. I'll get to you, Tiffany. RS, good. RS works. If anybody had TR or the RT, that works too. All right, that's a minor arc. And then how about major arc over here? Something bigger than a semicircle. Something bigger than a semicircle, John? RTS. RTS works for me. Yep. Or STR, that's fine. All right, any questions? Because now I'm going to go back to the theorem. Anything? All right, theorem, which, as you guys know, facts, right? And probably eventually these will go into our proofs when we hit them up sooner or later. First circle fact of the unit, here's a big one here. Relates the central angle to its arc measure. All right, and here it is. The measure of a central angle and we just talked, those are angles where the vertex is the center. The measure of the central angle is going to be equal to, ready for the big reveal, the measure of its arc. You guys don't have to fill this in. We're going to have plenty of practice on the next example, but let me just show you a little application of this theorem. RPS, angle RPS, does everyone agree that's a central angle? Because the vertex is at the center. If I know RPS is 50 degrees, guess what else is 50 degrees? The measure of arc RS is also 50. That's what that theorem is saying. And it only works for a central angle. Central angle always equal to its arc measure. All right, and if you're wondering, what's that mean, 50 degrees? How many total degrees in a circle? 360. So this 50 represents 50 out of 360. Okay, that's what it's telling me. All right, using that theorem now, let's do the next example. Let me do the first one with you, and then you guys can go on your own in your groups. I'm looking for the measure of arc AE. How many degrees are in arc AE? Well, I look at its central angle, ACE. How many degrees are in angle ACE? Using your geometry knowledge there. Bennett, what's good, brother? How ACE, what's its angle measure? Angle ACE. 1/3. ACE, angle 90, right? Because it's right next to another 90. So if that's 90, that means its arc AE also has to be 90 degrees. All right, that's the theorem I just showed you. A central angle is always equal to its arc measure. So go ahead. If you want to work, talk in your group, go ahead. If you want to try to roll it solo, do it solo. Follow the order of the letters. Central angle is equal to its arc measure. And you guys should be able to find all those angle measures in the circle, all those central angles. Oh, we ready. We're ready. Let's go. Arc ED. Let's roll. Arc ED. Whoo, Sophie, Arc ED. Come on, start us off right. 50 degrees. There you go. Yep. 50 degrees. DBA. Ooh, so we had to combine a couple arcs. A little arc addition. Woo. Deuce. Aylin. 20. What? 220. Got it. Anytime, stop me. I'll show you where it came from. AED now. Number 4. AED. Oh, Aylin again. Let's roll. 140. It just wasn't a coincidence last time. Good job. How about ABD? ABD. I don't know if anybody saw this or not before you actually added them together. And if you didn't, that's fine. Whoa, 1-3 here. Bennett, what's good, brother? ABD, number 5. Also 220. Heck, it's the same arc as number 3, just written differently. Oh, that guy got me on that one because I added them together. And then finish this off. BD, Bennett, come on. 130. You guys are on fire. All right, any questions there? How to find the arc measure? Because there's something else with an arc I need you to do here now. Any questions? Arc measure equal to its central angle. They all add up to 360, right? All right, something a little different, I think. Am I right? Yes. All right, now I got to do a good job here so you guys understand the difference of what we're going to do. You just found the arc measure, which is always in degrees. Before you leave today, I'm also going to show you how long it is, the arc length. So you already know, like if I take this one right here, we already know that that's 90 degrees, right? Don't write it on your notes. We already know that's 90 degrees, right? Because it's equal to its central angle. Now what I want to do with you, it's like I want to pretend I'm cutting it out, stretching it out, putting a ruler. How long is it? See the difference? The measure is in degrees. Now we're about to find out how long it is. All good before I should give you the formula to figure out how long it is. All right, so how do I figure out how long an arc is? Woo! Here we go. We first start with the fraction. On top of it is the measure of the arc, which you guys just found for me. So you're going to put the measure of the arc, and that's going to be in degrees, and we're going to plop that bad boy over 360, because there's 360 degrees in a circle. Oh, we aren't done yet. Then we're going to multiply it by a formula you are familiar with from yesterday. What was our formula from yesterday called? The circumference formula, and it was pi times d, or 2 pi r if you prefer. Now, hey, you're in what class here? So I just don't want to throw this at you and be like, eat it, go do it. Why is this going to work? Because think about it. We're taking a fraction of the, what's this formula for? The circumference. So what's circumference again? Distance around. So we're taking a part of it and finding an arc length. That's what we're doing. Okay, so that's where this formula comes from. I know you're like, shut up. I just want to do the problem so I can start my homework and have a good weekend. Anybody, big weekend plans? Weekend plans? Abby, what's good? For? Nice. Your, don't tell me. Your cello. Bass. What's the difference? No, I'm being serious. Like,
different strings, different octaves, different repertoire.
Same size?
No. Cellos are like that big. Basses are
bigger?
Yeah.
Okay. I was not aware of that. Okay. All right. Now I know there's there's what? Violin, viola?
cello, bass.
Cello, bass.
Yeah.
Am I missing anything else?
No.
You have to go to Connecticut to get this bad boy?
It's custom. So yeah.
Whoa.
It's like
What, to your height, or what's custom about it? Do they engrave your name in it? Because that would be a boss move.
I got to choose the wood and the style and everything.
What would you choose?
The back.
Cherry? Oak?
No, the back and sides are silver maple and the top is spruce.
Wow. Okay. Nice. All right. What's that, like a 2-hour drive? 3?
Yeah.
We're in Connecticut. Oh, nice. You're going to stay out there and do anything at the aquarium? Awesome aquarium out there. Okay. All right. Well, I want to make sure I ask you about it again on Monday. Anybody else? Big weekend plans going? Sophie?
I'm going to Potsdam.
Potsdam. Nice. Hockey?
Yeah.
That's a 3.5? 5? One of my friends went to college there, and the one time I visited, I just remember it was just all country roads. Like there's no, yeah, because that's right up near Canada, right? Pretty much. Okay. All weekend. All weekend. Don't listen to him. All weekend.
Yeah, I leave tonight.
Okay. Nice. All right. Here we go. Anybody else want to contribute before I go find the length of an arc? Okay. Everybody else just going to be in the corner of your rooms, balled up. Where are my friends? Type deal. It's all good. It's all good. All right. Let's do this. We're going to find the length of arc AB. All right. Arc AB. And yes, I know some of you probably could be like, hey, what do you mean? We're talking about minor arc AB here. All right. Minor arc AB. So let's first start off with what is the measure of minor arc AB up there? What is the degree measure of it? Emma, what's the degree measure of that arc? Also 90 because it's central angle. So I'm going to 90 over 360 times now the circumference, pi d. What's my diameter here? 20. Zach, what's my diameter?
I was confused to round it or
I'm not asking that. What is the diameter length?
Oh,
24. Pi. Now let's get to the directions. We've seen these directions. Leave your answer in terms of pi, which means your answer's got to have what in it? Pi. All right. Okay, ready? I'll help you. So it's got to have pi, but you still have a fraction and 24 to multiply. Yeah, we're not just leaving that as my answer. That's grotesque. All right? Grotesque. And that's actually an embarrassment to the math community if you leave it like that. All right? So we can at least multiply 90 over 360 times 24, and that'll give you what? Whoa, 6. Look at that. Ding, 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 ding. Lucia? 6. Oh, your number. Perfect. 6 pi. Yep. If you want to add in inches, you know how I feel about that.
Wait, so you just don't include the pi when you multiply?
Correct. And Zach, unless the directions now say nearest 10th, nearest 100th, then I use the pi button. Next up, CDE. Hey, follow the order of the letters. I'm looking for this major arc now. First step, what's the degree measure of that arc? Be careful what you say here. I know you see a number, but it's not that number. What is the degree measure of that arc I'm trying to find the length of? Zach, over to you. Here we go.
320.
320. 360 minus 40. Good. Times pi. What about the diameter in this case? Aylin, diameter? Third. What do you have? 18. Thank you. And we just talked. Leave your answer in terms of pi, but you can multiply everything else. And coming up here, sticks, Henry.
16 pi.
16 pi. No issues? All right, final one. Make sure, please follow the order of the letters. F to G to H. First, give me the measure of the arc. Measure of the arc here. Lucy, measure of the arc. 135. You had to add 90 and 45. Over 360 times pi. How about my diameter length here? Bennett. Diameter length. 6. Good work. And let's leave this in terms of pi. Fraction. I don't think the decimal's that crazy, so I would accept the decimal or fraction version. Just as long as the decimal's not running on forever, then I would prefer the fraction. All right, length of this arc with the pi here. Where am I going on that one? Going deep. Will, hello.
2.25.
2.25 pi. Good work. Woo! Any questions? Before I move on to the last one, which is going to be a little bit different. Measure versus length. Two different things, right? Measures in degrees. Length is actually how long it is. And then we get to this final one. A cart traveling around a circular track, of course. That's always going to happen. It's moving counterclockwise, 6.91 meters. So it's telling me the distance now. Everyone's seeing this. It's telling me the distance because I'm going to hit you up on these on the homework tonight, and I want to make sure you're ready for it. What is the measure of the central angle created by the minor arc AB? Oh, so now I'm actually finding that angle measure. Oh. Put on your big boy, big girl algebra pants here. First thing, let's do this. Let's do this. Scott, let's do this. What's the length of the arc?
6.91.
Okay, so I know the length of the arc. So that's how my formula is going to start out. We have been finding the length of the arc in the last three, but now we know it, and it's equal to the formula, which says measure of the arc, not 6.91. The measure is equal to the central angle we're trying to find, right? So that is what's going to be my x over what? 360 times pi. What's my diameter here? Shoom, Aylin? 4.8. Thank you. All right. Everyone all right with the setup? Because here's where you got to get your algebra pants on. Everyone's good with the setup? All right. We got to get x by itself. We got to get x by itself. There's a couple moves we could do to start getting x by itself. I don't want to call anybody and put anybody on the spot, but anybody got a move that would first try to start getting x by itself? Violet, what's your call?
Multiply by both sides by, divide both sides by 4.8 pi.
Okay. Method number one is I could get rid of the 4.8 in the pi by dividing both sides by pi. Is there another way I could start instead? Let's go over all the options. Kira?
U times 360.
Multiply both sides by 360, then divide by 4.8 pi. Either way, go. Whatever you prefer. So either we're getting rid of 4.8 pi by dividing first or multiplying by 360. Your call. And when do we round, by the way? At the end, yes. So if you're choosing to multiply by 360, don't round it. If you're choosing to divide by 4.8 pi, don't round it. Whew. If I can get the answer from this bad boy. What's up, Abby?
For the last we did on the last page,
Yeah.
the calculator gave me 9 pi over 4.
It gave you what?
9 pi over 4.
Yeah, that's if you do 9 over 4, that's 2.25.
Oh,
So if you left it like that, I'd be fine. Just as whoa, where are we going here, horses? As long as you don't put the pi in the bottom.
Yeah.
So don't put the pi in the denominator. Just put it off to the side or in the numerator. But yeah, so that's the same thing as 2.25. All right, what is the arc measure, which is also the central angle measure here? Whew. Finish it off here. What's that? Sophie, 21?
165.
What did it ask for? Nearest degree? You got me there. 165. Yep, 165 degrees. Be prepared. It's not always going to ask for arc length tonight. You will have to solve for the central angle. All right, let's roll, kids. See what you can get done.